This is problem number 3 from section 4.3. It says divide the first polynomial by the second. State the quotient and the remainder. Now you'll see our second polynomial is a binomial, and the binomial just has an x term. It's got a degree of 1. So because we have x minus 6, which resembles x minus k, we can use what's called synthetic division here. So we're going to use synthetic division. So when we use synthetic division, we take the k term, and that goes in the upper right-hand corner. So we have 6 up here, which is going to be our divisor. And then we've got to take the leading coefficients here from each of these. So we're going to take the leading coefficient of x cubed, which is 1, leading coefficient of x squared, which is -3, then -21, and then 18. And if there's ever a gap, we need to make sure we put a 0 in there for that gap. Now here's how synthetic division works. It's a series of multiplication and additions. So we essentially, step 1, we bring down the first coefficient, so we're bringing down 1. And then we're going to multiply, add, all the way to the end. All right, so we're going to take our k value 6, that's going to be the multiplication, times 1, gives you 6. Now we're going to add, -3 and 6 is 3. Now we multiply times 6 again, which is 18. And then we add, which is -3. Then we multiply, that's -18. And we add, and we get 0. Now, we're taking an x cubed function, a cubic function, dividing it by just an x function with a degree of 1. What are we going to end up with? We're going to end up with an x squared function. So, essentially, we just kind of work our way backwards, starting here. This is our constant piece. This is the remainder. This is the constant piece. This is the x piece. This is the x squared piece. So I kind of put those underneath, x squared, x, and this will just put constant. So we end up with x squared plus 3x minus 3, and this is the quotient. This is the quotient part. So we'll go ahead and circle that this is quotient. And the remainder is 0. And that's how you divide this polynomial by a binomial with a degree 1. We can use synthetic division to do that.